Okay, so now we have a contract where not only do we have a mechanism for setting our proposal, but we also have a way to vote either in favor or against said proposal. So now the next step, as I mentioned, is to find a way to help prevent against Sybil attacks where one person can create multiple wallets and easily vote, swing the vote in their favor. So what we are going to do is we're going to use a token to represent eligibility to vote in the DAO. And in particular, what we're going to do is we're going to have the DAO mint its own token. So we're going to have one method for mint DAO token. And then we're going to, actually, that's all we're going to do today. So all we're going to do in this segment is just mint the DAO token. And then in the next video, we'll go over how we actually use it. Just wanted to split it up a little bit because this is somewhat of a complex topic. It's not so much hard to understand. There's just a bit of like edge cases in code that we have to consider. So I figured it was easy to break it up into videos. So for this one, all we're going to do is make a method for minting the DAO token. So what I'm going to do is I'm going to create a method called bootstrap. And it's going to return an asset. So basically what's going to happen, someone calls the bootstrap method, the contract will mint a token, and then return that token that it minted. Now, in order to create a token on Algorand, it's pretty simple. We're just going to say const registered ASA. And in order to create a token on Algorand, all we have to do is send an asset config transaction to create a new token. So on other chains, you have to create a whole new contract to represent a token. On Algorand, tokens are a primitive feature of the blockchain. They're called Algorand standard assets. And we can use these Algorand standard assets, or ASAs, to represent both fungible tokens or non-fungible tokens. In our case, we're going to be creating a fungible token. So I'm going to call send asset creation. And in this send asset creation, it's expecting a couple of fields. I'm going to say the config asset total is going to be 1,000. In other words, there's going to be a total minted supply of 1,000 tokens. And because we're going to use this to determine whether someone can vote or not, this basically means the max amount of votes in our DAO is going to be 1,000, and only 1,000 people can participate in our DAO at any given time. So what we're going to do now is we are going to set another field saying config asset freeze. And what this is basically going to do is prevent the user. So once they register with a DAO, they can't send their DAO token to someone else. So by setting config asset freeze to a specific address, the address that you give it has the ability to freeze tokens in people's wallets. Now, of course, this is a completely optional field in asset creation. However, we want to use it to make sure that people aren't, selling their DAO membership after the fact. So what this send asset creation is going to do, it's going to mint 1,000 tokens. And it's going to allow this application, so this app address is the address of this application. It's going to allow the logic in this application to freeze and unfreeze assets in any given account of the DAO token, of course, or as we call it, the registered ASA. And then what we're going to do is we're simply going to return registered ASA. Now, one thing I also want to do is I'm going to go ahead and set a new property here. I'm going to say registered ASA. That's going to be a global state key. And here we're going to say it's an asset. Okay. So now at this point, we have this bootstrap method that we can call in order to mint an asset. So let's go ahead and try to do that. So what I'm going to do is come over to our test here. And let me make sure I put this in the right place. Yeah, so I'm going to come below get proposal. I'm going to write a new test. It's going to be called, bootstrap. And this is going to be an async method. And what we basically want to happen is we're going to await app client dot, oh, I forgot to build. So first let me do an npm run build. Okay, let's just try calling the bootstrap outright and see what happens. So if I do an npm run test, we're going to build again. You'll see it when actually, while we're developing this, I'm just going to skip this test. So what happened here? Oh, this was incorrect. Okay, so let me, good thing I didn't skip the test right away. Okay, so let me go ahead and run this again. So now what we should see, and by the way, by the time this video is posted, I'll fix this, so you won't have to fix that. Anyways, so let's go into the actual problem I want to focus on here. And we can see here that we encountered an error when we tried to send our inner transaction. Now, unfortunately, just for whatever reason, cuts off our error message. So I'm just going to write some code. You don't have to do this. I'm just doing this to kind of demonstrate what's actually happening here. And we're going to do console.warn e, and then we'll throw e again. Okay, so if I come down here again, let's take a look and see why our bootstrap method is failing. Okay, so come up here. I got this beautiful error message, all to say the fee is too small. Okay, so why is it saying that, right? We've sent all these other method calls just fine. So the reason it's saying fee too small is because here in our DAO, we send an asset creation transaction, and that transaction, its fees need to get paid. You can see here, if we wanted to, we could specify the fee, but that would pay from the contract account, and we don't want that to happen. So the fee is 0, right? By default, if you don't set a fee, it's going to be 0. So what does this mean for our client? Well, it means that when we call it client side, we need to double our fee, right? So by default, every Algorand fee, so default fee per transaction is 0.001 algo or 1000 micro algo. So Bootstrap sends one inner transaction, so 2 transactions total. Thus, our fee needs to be 2000 micro algo. Okay, so how do we update our fee? So to call our method, right, I mentioned our first argument is the arguments to the on-chain method. And our second argument is going to be parameters on the client side. So we're going to say our send params, and we're going to set our fee to algokit.microalgos 2000. Okay. So when we send this transaction, the account sending the transaction, instead of just paying 1000, it's going to pay 2000 micro algo. So let's go ahead. Now that we've dealt with the inner transaction fee, let's build it again and see what happens. Or test it again, I should say. And we still ran into a failure. So what's going on here? Now we can see that we got this error, balance 0 below min 2000. And this brings us to a very important concept in Algorand called minimum balance requirement. So by default, every account on the network needs to have at least 0.1 algo or 100,000 micro algo. And so that's just the default balance that you need to have in order to be included in the ledger. If your account has 0 algo in it, then the ledger isn't keeping track of it, which makes sense, right? Like, why take up space in the ledger if you don't have anything? So by default, if we want an account to show up in the ledger, we need 0.1 algo or 100,000 micro algo. However, anytime we create an asset that also increases the minimum balance requirement by an additional 0.1 algo. So anytime we do something on chain that increases the amount of space we're taking up on chain, so when we create an asset that adds something to the Algorand database, thus making it bigger, so we need to pay for that space somehow. And the way we pay for that space is through the minimum balance requirement. So what this error message is saying is that our contract is trying to hold one asset, but it has 0 algo. So it's not even in the ledger, and it has less than 200,000. And we need 200,000 because it needs the 100,000 to be in the ledger, and then an additional 100,000 to hold an asset. Now this can be a little bit confusing at first, so in the description of this video and in the bootcamp, we'll give you links to the developer docs, the developer portal, where we kind of explain minimum balance requirement in a bit more depth. But the key here is, in order for our contract to hold a asset, the asset that it creates, it needs to have 200,000 micro algo. So to do that, what we're going to do is we're going to call await app client dot app client dot fund app account. And we're just going to simply pass in algo kit dot micro algos 200,000. Okay, so let's go ahead and run this again. If all goes according to plan, we should now have a passing test. Okay, great. And one thing we do want to do is we want to set, so we're going to just say const bootstrap result, and we're going to set we're going to have a new variable. So I'm going to come up here and say let registered ASA be a big int, right? Because it's a UN64, so it's going to be a big int. And actually, let me get rid of this try catch thing here. And then our registered ASA is going to equal bootstrap result dot return dot value. Why is this complaining? Oh, max line length. So I think I should be able to do it like this. Okay. So let me match exactly how I have it in my notes, just so when we push, it's not a surprise. Okay. Oh, and we're going to change this to an exclamation point. Okay. And for those that aren't familiar with JavaScript, or TypeScript, I should say, so when we have a question mark here, so actually let me get rid of this question mark. If we don't have a question mark, it's going to tell us that it's possibly undefined. A question mark tells TypeScript that it's okay if this is undefined. An exclamation point says we know that this is not undefined, right? And we know if our bootstrap method works, then this will not be undefined. Okay, so, and then let's just go ahead and we can do a console log here just to show that this works. Give it a minute. Okay, and we can now see that this registered ASA does indeed work. So now what we want to do, oh, I forgot to show you the console log. We can see here it logs. So an asset ID on Algorand is just a UN64. So the asset that we created was ID 1109. Okay, so we've created our bootstrap method, but now what we want to do is we want to do two things. First, what we want to do is we want to make sure that this method is only callable once. So if I come in here, what I basically want to happen is I want to assert that, okay, I want to assert the negative of this registered ASA ID dot, oh, no, it's not registered ASA ID, it's just registered ASA exist. So to give some context here, so this assert, what the assert command does, it's very similar to like a Python assert if you're familiar with Python. But basically what we're doing is saying, if this condition is true, then continue on. But if it's false, then throw an error. Okay? So basically what we're saying is only allow this method to be callable once. Right? So we only want this method to be called once. And when we do call it, oh, and I just realized I also forgot to set this. Okay, so once we do call it, we're going to set a registered ASA value, and that will prevent it from being called again. So what this function is going to do, it's going to check to see, has this function already been called? And it'll do that by seeing if registered ASA has already been set. And if so, it's just going to fail for us. Now, the other thing I want to do is I want to protect this method to make it only callable by the application creator. Now, in the context of what we have right now, this isn't particularly super important because we already have protections to make sure it's only called once. So technically anyone can call it and that would be fine. But for demonstration purposes, I want to show how we can verify that the person calling this contract is the app creator. And this is a very common pattern. Generally, you either check if it's the contract creator, or in your contract, you have some state defining who the admin is. In our case, we just want to verify, that the person calling this is the person that created the app. So to do that, I'm going to use this verify transaction function. And what this function does is it allows us to verify specific fields in a transaction. So if I called it verify transaction, I want to verify a field in this transaction. And then I specify what field I want to verify. So I want to verify the sender is equal to this app creator. Okay, so what's basically going to happen is if I try to call this method and I am not the app creator, then it will simply fail. So to demonstrate how that works, what I'm going to do is I'm going to come back over to our tests. And I'm going to make a new argument here. I'm going to say let sender equal, actually, no, that's not going to be equal. It's just going to be an algo SDK dot account. And then here in my before all, I'm going to generate a new account. So previously, this whole time, everything we've sent has been from this one account, test account. But it's common in your testing that you want to involve multiple accounts. So the easiest way to do that is if we get a new account from RKMD. So first, actually, before I do that, let me quickly show you. So if we do an algokit localnet, we can see here we have a couple of commands. And the command we want to run is algokit localnet. I thought there was a goal command. Goal account list. Maybe it's just not listed for some reason. Oh, okay. I guess we have to do algokit localnet console. And then if we do a goal account list, we can see here we have multiple accounts here in our local net. So these are all accounts stored in KMD. And what we basically want to do is create a new account that we store in KMD. So to do this, we're going to say sender. It's going to be equal to await, get, or create KMD wallet account. The name is going to be TEALScript DAO sender, and we're going to call fund with, and that's going to be algokit.algos10. Oops. So we're going to give this, we're going to create an account and name it TEALScript DAO sender, and then it's going to fund it with 10 algos. Right? So if I call algo D, this is also going to be KMD. Okay. So up here, we've just added KMD to get it from the context here. And then we are setting our sender. So the first time we call this, it's going to create an account called TEALScript DAO sender, fund with 10 algos. And then the second time we call it, it's just going to get that same account because it saved the name. So what we want to test now is we're going to try to call this bootstrap method. So I'm actually going to copy this. And first, let's test the negative. Okay, so what we're basically going to do is we're going to, in our call, we're going to set the sender to this new account that we created, right? So we create the contract with our test account, and then we're going to try to call the bootstrap method with our sender account. I'm going to go ahead and skip this for now. Right. We can delete this. You don't have to delete it, but I'm just going to delete it to save some algos. So if I exit out of my algokit console and I do a npm run test, right, we expect this bootstrap negative to fail. Right, and we can see here we're getting the creator of this app. Is it equal to the address that we passed in or the address that we called the application with? And it's not, so it's throwing an error. And that's exactly what this verify transaction function is doing. Okay, so now let me just go ahead and update this. We're going to await, expect, okay, get client not bootstrap. Dot rejects dot to throw. Okay, so now we're saying because we're calling it with an account other than the test account we created the app with, we expect this to fail. Okay. So again, to kind of recap, we created a new account in the network, and then we've gone ahead and we added a test that tries to call the bootstrap method from that account. And we expect it to fail because we verified that the transaction sender is this app creator. which is not true because we might have manually changed the account. And now if we come ahead and we retest our bootstrap call here, we should now see that our bootstrap method is passing. Oh, and we skipped. Let me just unskip this so we can show all the tests running. Or all the tests passing, I should say. Okay. Now, the one thing that we're missing here is ideally we have a function to return our registered ASA. So we're going to pretty much just copy this, return a number, no, actually return an asset, and we're going to return this dot registered ASA dot value, get registered ASA, and then we're going to come down to our get proposal method, and after we bootstrapped, I'm just going to copy that and call get registered ASA. And then it's going to complain because it hasn't built yet. So I'm going to do an npm run test, which should get rid of that error. And then we should see, oh, I just realized I need to fix this. And then we now should see oops. And we expect this to be registered ASA. Give it a second. The more tests we add, the longer it takes to run. If you're familiar with the JavaScript ecosystem and you're comfortable using Bun, I personally recommend using Bun. In my experience, tests against a local network are like 3 times faster than Node.js, but we're just going to stick with Node.js to keep it simple. But you can see here that we've now, passed all of our tests. Okay, so at this point, what we've done is we've minted our DAO token in the Bootstrap method, and we verified that only the creator can call Bootstrap and that we actually are bootstrapping successfully. And then we could get our registered ASA. Okay, so now the next step is going to be actually using this ASA. And again, if you're new to Algorand, there's going to be some concepts that you might find difficult to navigate exploring on yourself. However, the next step, what we're basically going to do is we're going to have a register method that uses inner transactions to send and freeze the ASA in the caller's account. Okay, so I'm going to go ahead and this video here. And if you're interested in seeing how we actually use this ASA to allow people to register and to block voting, stay tuned to the next video. I'll see you then.